Hi, I'm Yongshi. Now I'm doing the assignment 4 of math in this semester. Today I'm going to talk about the second order derivative, which known as the change of change. So why we should care about the change of change? So let's explore the ideas by looking at its significance and examples. First of all, let's look at the diagram here. This diagram is from the paper written by King, that is astrophysics. The planetary orbit changes directly connect to the second derivative. As you can see, there are three tangent lines that shows the different speed and also the different accelerations of our satellites. So what is the second derivative? So simply put, they measure the rate at which the rate of change is changing. So for instance, if we think of the satellite's motion, the first derivative is the speed, while the second derivative is the acceleration. The definition of this theory is the derivative of the first derivative, that is the second derivative. So you can see the mathematical expressions here. The third one, named in honor of 17th century German mathematician Gottfried, and those are different kind of things you can show that is the second derivative. So what can we do with the second derivative? We can find the local maxima and local minima using the second derivative. So visualization is the key to understand this kind of concept. A positive second derivative means our curve is concave up like a bow. A negative second derivative means the curve is concave down like an arch. So here shows the two different functions. The first function is the 3x squared minus 8x. You can find here is the local minima, and this is the tangent line of this point. And this tangent line, the slope of this tangent line equals 0. And the second graph is the function of this. You can find here is the local minima. Oh, sorry. Here is the local maxima, and here is the local minima. So those two line is the tangent line. The slope equals 0. I want to show you the graph of the sine 2x. You can see the slope change of this sine 2x function. So here is a turning point. You can see the color change, and it will reach the another. Here is the another turning point. Why we call this is the turning point? It is because of the second derivative, and also the slope changes because of the second derivative. To be more specific, I dropped this, and please ignore my by drawing. So those are the tangent line. So this two is positive. This two is positive tangent line, and this 4 is negative tangent line. You can find the local maxima here, and also you can find the local minima here, So the turning point, there are 5 turning point of this graph. 1, 2, 3, 4, 5. So why this is the turning point? Because of at this point the second derivative equals 0. The second derivative equals 0 as the graph reached the highest and the lowest, highest and the lowest slope. Here reach the highest slope. Here reach the lowest slope. Let's dive into the real world example. Like you can take a look at the stock price graph. Here you can find the local maxima and the local minima. Probably we can use the second derivative philosophy or second derivative knowledge to identify if the price will going down or going up. Also, in modern technology has made the second derivative even more powerful through Python. Like use the SymPy for symbolic differentiation. Leverage LongPy, SymPy for numerical derivative on real-world data. Also, I wrote this uh, code and I get this kind of graph. You can have a look. That is the original function here, and also the second derivative here. That is second derivative and also a first derivative. A conclusion of my mini presentation. So the second order derivative are not just theoretical constructs. They provide deep insights into how things change over time. They are indispensable in optimizations, also in data science, physics, and also in economics. By leveraging the Python, we can turn these insights into practical solutions. Thanks for your listening. That is my mini presentation.